Hello everyone, welcome to my course Signals and Systems. In this unit we will learn about what is a signal, what is a system, definition of a signal and then definitions of systems. Then we will see what are the types of signals, what are the operations which we are going to perform on the signals, and then we will also see about what is the analogy between vectors and signals so that we can apply all the properties of vectors onto the signal. In the same course, we will also learn about transformation techniques like Fourier series, Fourier transformations, which will convert a signal from time domain to frequency domain. And we will also learn about Laplace transformations, which will convert a signal from time domain to S domain. And then we will also discuss about Z transformations. There we will see how to convert a signal from time domain to Z domain. And in the same course, you will also learn about the signal transmission through the linear system, a very important category where we will work with LTI, linear time invariant systems. They will find how to get the system response, transfer function, frequency response, etc. And in the same course, we will also learn about a sampling theorem. The sampling theorem will tell us how to convert a signal from continuous to its samples and how to get it back to its continuous form. And in the same unit, we will also learn about correlation, convolution, energy spectral density and power spectral density. So this is about the course Signals and Systems. So coming to the today's topic, that is introduction to the course, there we will see about what is a signal, what are the different types of signals, what are examples of signals. So all those things we are going to see now. Signal is any physical quantity that varies with respect to time, space or any other independent variable. Look at the graph. Here you can see the signal is varying with respect to the time. So sine wave is like this and then square wave is like this. So here you can observe clearly on the x-axis the signal is starting at origin and it is varying with respect to the time. All the values which we are plotting here are with respect to the x-axis and y-axis. So the signal which is on the y-axis, I mentioned it as sine t, a sine wave or a sine signal, is varying with respect to the time. It is defined at every time instant on the x-axis. So I can say the definition like this. It is any physical quantity which varies with respect to time, space or any other independent variable. So that is the standard definition of a signal. And sometimes we can also say a signal is any physical quantity which carries information or conveys information. Even that also we can use, but this is not that a standard definition. We can, for our understanding purpose, we can use this definition. Signal carries information. Like for example, a traffic signal. Traffic signal is giving us information. Like whenever green signal comes, we have to move. We have a permission to move from that particular junction. Whenever red signal appears, it indicates that we are supposed to stop there only. And whenever there is a orange signal before the red appears, it indicates that we have to immediately, as soon as possible, cross that junction. So those three signals which are giving us information. So like that, there are so many other types of general examples of signals. Like the board, sign board, which indicates that I have to move to the left side or right side at a particular junction so that I can reach my desired destination. And a particular board which indicates that how many kilometers I have to or how many miles I have to travel to reach my particular destination. And there are some general signals, like with the gestures also we can say, yes, you can answer my question. This question is for you. Hey, are you watching me or not? So like that, this particular thing, gestures also will gives some information. So a signal carries information and according to that others will react. And some of you, if I ask you what is the definition, what are the examples of a signal, some of you will immediately recall general things like telephone signals, the signal in your mobile battery, and then some of you will think about signals which are related to the radio, like FM radios and AM radios. And some of you may even think behind that there are some radar signals, such kind of things. So signals, there are so many general examples of signals, and the standard definition which I told just now, it is any physical quantity. Signal is any physical quantity, and you, even right now, you all of you who are watching me, is a type of signal only. My image is being captured by your eye, and then it will process those images at a faster rate so that you can view me in just like a video in front of you. Even if I am live in front of you also, the same thing, whatever I told you is applicable to that. So your eye will process that information and send it to the brain. Then you will watch me just like a person who is standing in front of you and moving here and there. So like that, everything is a signal. And to make you curious about the subject and to make you to involve more into the readings related to this course, I will tell you one information. This is also one type of thing which I can make you to attract towards my course. I used to give the same example to many other batches. So let me give the same example. So whenever a particular thing happens, say for example, we are discussing about a crime scene. In a particular room, a crime happens. Somebody, a group of people, or two or at least one person, killed another person and he left that place. So immediately after half an hour, obviously after half an hour, the clues team will come, and then what they will see is everything. They won't allow anybody to enter into that place, and they will take some clues. This is the current technology they are using to identify which person came into that room, so that by the help of the forensic, all those things, they will use dogs and all those things, and then they want to catch. But there are chances that in the coming future, in next decade, if we don't know, it may come even earlier, with the help of the new technologies, emerging technologies which are coming, we can recreate the same scene, whatever that happened exactly before 30 minutes or even before 1 hour. So if you recall from your movies, previous movies, olden days movies, whenever something happens, one particular person will be having some thing in his hand. We will call it as a mantra dandam in his hand, and he will utter some chanting and he will just put it under the wall. So that scene will be shown there. So he will, with this knowledge, we will call it as Divya Drushti. So he will narrate that what happened at that time, at that particular place, to the other person who approached him. So same thing, the same concept may appear here also. So how it is possible? Because, say for example, I am moving here in this particular room, you can watch me. I said just now it's a signal, it's a type of signal. Signal strength is good so that you can catch it. If I leave away from this place, so I am moving away from this place, so signal strength is lost. You cannot see the signal anymore. Now the signal strength is there. You can see it. So what we can do is, with the help of the different transformation techniques which we can perform on a particular signal, take a signal as input and play with the signal with different types of techniques, whatever that you are going to learn in this course, so that you can get the signal strength back. Whatever the signal was there 30 minutes before, you can get its strength back, and you can observe what happened exactly at that time. So it may be reality with your research. I hope you and me, if I am not me, or otherwise you at least, can do this kind of research in the near future. So with this thing, let us move to the second diagram here. This is another diagram which I drawn as an example of signal again. It is any physical quantity which is varying, but it remains constant here. It is growing. It's a growing curve. It started here and reached up to here. It is 1. That is when pi by 2 it is 1, sin pi by 2. And then it is pi, when sin pi it is 0 again. Again it is minus 1 and then again 0. So signal strength is increasing like this. 0, it became 1 and 0, minus 1 and 0. But whereas here it is constant. From 0 to pi it is constant, 1 only. Thereafter it is minus 1. So what I want to tell you here is, this is an example of a sine wave. So I can write directly like this. This x of t, I can give a name to the signal. So I am introducing you this concept called notation of a signal. Signal notation. So x of t is equal to sine t. So in the definition I told, it is any physical quantity. The signal is any physical quantity which varies with respect to the time. Okay, so that's why I wrote x of t. This x of t is called as a function or signal notation, and that this thing which is inside the bracket indicates independent variable, and the independent variable in our case here is time. So x of t is equal to sine t. Even directly you can write sine t, or you can write x of t is equal to sine t also. And here I wrote f of t is equal to, it's a square wave, it's a square signal. So f of t is equal to square of t you can write. Okay, so this is called the definition of a signal. I repeat again, it is any physical quantity which varies with respect to time, space or any other independent variable. And coming to the next one more step in advance to this. So we can represent this entire signal like whatever that I have drawn here. This is called as the graphical representation of a signal, and this is called as mathematical representation of a signal. Okay, so a signal can be represented graphically, like you can draw it, or otherwise you can just pronounce, give a definition. Orally you can tell it is any physical quantity which varies with respect to time, space or any other independent variable. And you can write it like this, x of t is equal to sine t. Okay, so similarly here also we can write like that. So f of t, in this case it will be equal to 1. How long it is 1? From 0 to pi. So that you can write like this. F of t is equal to 1, 0 less than or equal to t, less than or equal to pi by 2. Sorry, pi. Up to 0 to pi it is t. And then that is equal to minus 1 for pi less than or equal to t and less than or equal to 2 pi. Like this we can write. So between 0 to pi, the signal is, the signal value is 1, and from pi to 2 pi it is minus 1. Okay. So now let me introduce 3 more terms here. One is what is called as amplitude of a signal, and what is called as time period of a signal, and what is called as the frequency of a signal. So if you look at this signal amplitude is 1. The maximum value, in this case it is also 1. So the maximum value which the signal is having, here it is having 1, and here also it is having 1, and here it is having minus 1, and here also it is having minus 1. So the maximum value in this case is 1. 0 to 1 it is 1, and 0 to minus 1 also it is 1. So I can say that amplitude of the signal is 1 year, and the time period of the signal is, this is one cycle of square wave, this is one cycle of sine wave. So this is called as one time period, and the frequency is, in one particular time period how many such cycles are there, then that will be the frequency. So here the frequency is 1 because only one cycle is there in the one time period. So if it is in one time period, if I have 2 cycles of sine wave, then the frequency will be 2 or 10. If 10 cycles of sine wave, then the frequency will be 10. So in the coming modules, we will learn about in detail what is frequency, what is amplitude, and what is the time period. We will focus more on the time period and amplitudes. So we will learn about them in the coming future. But these are important: definition, mathematical representation, and then graphical representation of a signal. Now coming to the types of signals. We have discussed about general examples of signals. But coming to the types of signals, signals are of three types. One is one-dimensional signal and two-dimensional signal or multi-dimensional signal, and the other one is multi-channel signal. Okay, so what is called as a one-dimensional signal is a signal which is having only one independent variable. In this case, it is having only one independent variable. So this is called as one-dimensional signal. A signal which is having two independent variables. Say for example, if I write x of t1 comma t2 is equal to something, then this is called as two-dimensional signal or multi-dimensional signal. Then coming to the third one, multi-channel. What is called as a multi-channel signal is a signal which is generated by multiple sources. Say for example, ECG or EEG. The output which is coming out of these devices is because of the multiple sensors which are connected to the patient body. So such a signal is generated with the help of multiple sources. So a signal which is generated by multiple sources is called as multi-channel signal. A signal which is having only one independent variable is called as one-dimensional signal. A signal which is having two or more than two independent variables is called as two-dimensional or multi-dimensional signals, depending upon the how many number of independent variables we have. Hope this is clear. Definition, and then graphical representation, mathematical representation, and then types. Then we will discuss about three other important types of the signal in the next module. They are analog, discrete, and digital. So explore about these three topics so that the next discussion will be easily understandable for you.